All right, now we're going to talk about keeping time. So, like on watches and that sort of thing. Um, so, the day is defined, astronomically speaking, as 24. We set it up for 24 hours. Now, 24 hours, that's a Babylonian thing, and it's nominally defined from noon to noon, although the religion that I was raised in, sort of, starts the day at sunrise at sunset and goes until sunset the following day. So basically, the point is that noon to noon, or the other civilizations have other ways of characterizing it. Uh, and as it says, the sun goes around once a day. It's easier to define when the sun is directly overhead, though. And we don't mean at your zenith. We mean sometime, some point where the sun is highest in the sky, so highest elevation. Okay. All right. A sidereal day is different, though, as exemplified in this picture, particularly the one on the on the right-hand side. So here we are. The Earth is rotating about its axis. And here, this is noontime, and then it goes around, not only does it go around its axis, but it goes around in its orbit about the sun. And so if there is a star out here that you can identify, and you're rotating about the sun, and rotating about your axis, then you're going to see the star sooner over here than you're going to see the sun in the same position. So this lag in time is about 1 degree, meaning that we have about 4 minutes per day that's different. So the stellar day is 4 minutes shorter than the solar day. You can also think about it in this fashion, that the Earth rotates 365 times in a year, but it also has rotated once because it has gone around the orbit of the sun once. So 366 relative to the stars. Okay, as it says here, we organize our lives according to the sun, but after all, the nighttime sky changes during the course of the year. So, what is noon? I've inherited these charts from a friend who's really into movies. My consideration for you, though, in this idea is to consider the movies of Back to the Future and consider the clock tower. The clock tower was a significant character, although it didn't have a real speaking role in all of the movies. Time is defined locally because, after all, the sun appears in the daytime sky in the highest point differently for different places on the surface of the Earth. And so, locally, there's going to be a difference in noontime astronomically from Pasadena to Santa Monica. And that's something one can calculate. But the problem, though, is once you start traveling around, then keeping time becomes more complicated. So when we travel and we're trying to maintain schedules, say, for example, a railroad going from New York to Boston, you would go through different times associated with all the little towns that you're moving through. New Haven, Connecticut, Long Island, what have you. I don't know the names that well. Cape Cod. And as I said, I just don't know. But the point being, though, is that every single location has a different noontime, slightly different. And if you have trains that are moving through space and you are saying that you're going to go through a particular town at this moment in time, is it Boston time? Is it New Haven time? Is it New York time? And what about the train that's going in the opposite direction? Not until recently, not unless there's enough traffic, do you have several train tracks going from one location to another. So you would have to make sure that everybody is synchronized with the same clock so that you do not have one train going in one direction and another train going into another direction on the same location in space. So that can be a problem. So what people did was they broke down the surface of the Earth into roughly 24 slices, and in each one of these slices, everybody keeps track of the time with the same clock. So everybody here, right now, it's about 12 minutes to 4 o'clock. So here it's every place here it's the same time. Everybody can look together and see the same time, and then over here it's 1 hour different, 2 hours different, 3 hours different, and so on. Now you'll notice that not everywhere do we share, is it the same sloth type, same slice as you would see. Like here it's kind of wide, here it sort of tilts over. So there are other considerations. Now, calendars are kind of an interesting thing. That's the real reason that Julius Caesar was killed. We have 3 cycles to reconcile, and none of them don't divide into each other easily. A month is really 29 and a half days. A year is really 365 plus 24, 25, something else, and obviously they don't match up very well. The Julian calendar, basically the issue here, if you look it up, you find out that there was a lot of corruption associated with calendars, and the pontiff, yes, the pontiff was the person who devised when the calendar was, was the keeper of the calendar. There was a lot of corruption associated with that, because if you control time, then you can also control how people get paid and how the money changing hands. So this idea, though, 365.25 days, was something that you could really work out pretty well. You have a nominal year that's 365, and then every 4 years, as you well know, you have another day that you add on, and that accounts for, that's the leap year. So 365 3 times, and then 366 for 1 time, and that averages out to 365.25, and everybody knows how to do that. So you take out of the hands of the pontiff a source of corruption. Now, it isn't perfect, and that was found out by Gregory, and they found, and basically over the millennia, then their springtime festival of Easter became a wintertime festival, and that couldn't, that wasn't any good. So they had to fix that. So the way they did it there, we get to 365.2425 days. And the way that you fix that is by looking at years that are divisible by 400. They're already divisible by 4, so they ought to be a leap year. But when you are divisible by 400, you say, no, I'm not going to have a leap year. And then you continue. So the year 2000, we actually had a leap year. There are other calendars, and they are more representative of, the Islamic calendar has 28 days, or 29 days, and so every year their year is 11 days shorter, and so it rotates about. So that's why you get Ramadan being in different seasons. Now, mind you, most Islamic people live close to the equator, so that's no big deal. So here we go. And I include the Mayan calendar just for completeness sake, since, you know, the 2012 theories are worrying about the Mayan calendar, and okay, well, there's not much there. Okay, now the equation of time comes on, and that's kind of interesting. And the picture here is basically, if you take a look at a a sundial and compare that to your watch, you're going to get differing answers, you know, even though you're going to have the seasons affecting it. You already know that, as well as standard time versus daylight savings. And the effect there that we're looking at is the actual movement of the Earth is one that is causing another effect. Okay, and this is the equation of time. It has two effects in there. One is associated with the rotation about the speed at which we're going around the Earth, and the other one is having to do with the seasons. So that when we're further away from the sun, sorry about that. When we're further away from the sun, then the speed at which we're going around the Earth's orbit slows down. So in our winter time, we are moving quickly, and so as we are moving quickly, then the difference between an atomic clock and a solar clock here during December is going to be on the negative side, and as we are going around in the summertime, we are going to have the opposite effect. We're going to be slowing down, and so we're going to be getting out of kilter between where the sun is and the rotation. So the rotation of the Earth is the same going around either winter or summer, but our speed going around the sun is different. So the noon time is going to be different. It's kind of an interesting effect. Okay, enough of that.